Okay, so here's an example. You may have this number. Yep. So here, I'm going to read it to you. Are you ready? I'm reading the number that you're writing. You're writing down 0.00000000134. I'm going to say it again. 0 point, and then you put 10 zeros in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you end it with 1, 3, 4. Ladies and gentlemen, this is a hard number to read, isn't it?
Yeah. That would be like billions.
I mean, let's see. Tens, hundreds, thousands, 10,000s, 100,000s, millionths, 10 millionths, 100 millionths, billions, 10 billions, 100 billions, trillions, 10 trillions. So 134 10 trillionths. But even then, counting to read it correctly took time. It's not fluid. It's too big, technically. It's too small of a number, right? It's less than 0 or less than 1. It's a tiny little tiny number. I mean, like, would you want to measure that? No, it's too small to measure. So this is a very small number. Or we have this number, which is 4, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 zeros. I mean, that's ridiculous. Again, looking at this number, it's too big to read fluently. Like if I'm reading along in an article and I come across this number, I don't know what number that is. I know that it's really big, but I don't know what number it is. I can't read it fluently. If we look, it's, let's see, hundreds, thousands, millions, billions, trillions. What comes after trillion? A lot, right? I think it's actually, I don't know. It's too big, right? It's too big. So, these are called
big numbers.
Standard notation. These types of numbers, regular old numbers, are called standard notation. Meaning this is how numbers are typically written, right? We put commas after every 3 decimals. There's one value in front of the, I mean, like, this is how they're written. But the problem with these standard numbers, the problem with this is that they can't be read. Right? Again, if I'm reading a story and this number's in it, I can't read that number. I'd have to gloss over it. If I'm giving a presentation and this is the amount of honeybees that are across the world, I can't express that value to you. It's too big to say. So what we do is we convert. What does it mean to convert? To change. We convert standard notation into scientific notation. So we take a standard, a regular old number, and we convert it to scientific notation. We make it easier. It takes up less space. So here are the rules. There are 5 easy steps. Are you ready? Step number 1. Find the decimal. Does that seem like a hard question or a step? It's pretty easy, right? In fact, if I look at this first number, can you find the decimal? Oh, look, it's right there. Okay, so interesting point. Looking at the second one, can we find the decimal? And I heard, but there isn't a decimal. And you're right, there isn't one showing. But BB, where is it? It's right here at the end. We just don't put it because it's not necessary. So step number 1 is find the decimal. That seems easy. John, sit up, please. Number 2, this is the part that sometimes messes us up. You're going to move the decimal so there is 1 non-zero digit to the left of the decimal. So you want to move your decimal now, and you're going to move your decimal as many times as you need to until there is 1 non-zero digit to the left. Ladies and gentlemen, for those of us that still struggle with left and right, your left hand makes the letter L. Your right hand does not make the letter L. You say, but Mrs. Long, if I flip it over, I get it. That's not what we do. If you hold your hands in front of you, your left hand makes the letter L. Most of you, so let's do step 2 to our 2 examples up here. Step 1 was find the decimal, which is right here. Step 2 is move the decimal so there's 1 non-zero digit to the left. And if I look, there's 1 digit to the left, but what is it?
0.
And I don't want 0, so I'm going to move it to right there. It's still 0. So I'm going to move it again. Still zeros. So you keep going. And I stop right there. Because my non-zero digit to the left is the number 1. So my new problem is now 1.34. So step 3 is write the new decimal. Instead of having 0.000000000000134, I moved my decimal so there's 1 non-zero digit to the left. So now my new decimal is 1.34. 4.34, which is way easier, isn't it,
Yes.
John?
Yeah.
All the way up. Head up. Come on. Let's try this one. There's a whole bunch to the left. I want one non-zero digit to the left. So I move it once. I keep moving it. I keep moving it. Keep going until there's one non-zero digit to the left. Should I stop here? No, because it's 4, 3. There are 2 non-zero digits to the left. I move it again. So there's 4. There's 1 non-zero digit to the left. So it's 4.3. Gabe. So we have our new decimal. Easy. Step number 4. Count the number of moves you made write the new decimal. And we're on step number 4. You should have also moved these decimals up here and should have the new decimal right next to it. You need to be on task. Count the number of moves you made. Ladies and gentlemen, this is your exponent.
Really? Oh, that's sad.
Because remember what we talked about yesterday? It's going to flip over. 10 to the 4th means that there are 4 zeros behind it. Right? We moved our decimal 4 times. 10 to the 3rd means we moved our decimal 3 times. 10 to the negative 2 means you moved your decimal left 2. And if you look at how many zeros we have on this page. These are base 10s. Every time you move one place value, that's a 10. Because if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I move away from the single to the double. Right? So, step number 5 is always times 10. Always times 10. And this is scientific notation. So let's look at those examples. 1.34 times 10, always times 10. And count the number of moves you made. This is your exponent. So we moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? You count. Am I right?
Yeah.
So it's to the 11th. But is it positive or negative? Look at your base 10s. What kind of exponents were on numbers that looked like this? Look at your base 10 page. Yesterday's notes, the last page, page 40, 42.
Wouldn't it be positive?
Nope, it's negative.
Why is it negative?
Because there's so many decimals.
Because numbers that have 0 point, numbers that look like this, have what kind of exponents? Negative exponents. So it's negative 11. Don't worry about that. You worry about what the number looks like. So you put negative 11. See if you can do the next one. See if you can figure out that bottom one, the second example that we did. So it's 4.3 always times 10. Always times 10. And let's see, I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Positive or negative? Because it's a big number, it's a positive 16. Big numbers have big exponents, positive exponents. Little numbers have little exponents, negative exponents. Let's do a few practice. Are you ready? Okay, write down this number, 8694, and then 6 zeros. 8694, and then 6 zeros. Sit up. Sit up. Write down this example. All right, step number 1. It's my favorite one. Find the decimal. Where is it? On the very right. Step number 2. Move it so there's one non-zero digit to the left. Right there. Step number 2 or 3, write the new decimal. So 8.694. Really, we should probably switch step 4 and step 5, right?
Yeah.
Always times 10, no matter what. And then how many times did we move?
It was 9.
Let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's good. And it's positive 9 because it's a big number, right? That's your answer. Let's try this. Okay, here we go. 0 point. And then you put 7 zeros. 0 point. And then 7 zeros. And then 708. Find the decimal. Found it. Right here. Move it so there's one non-zero digit to the left. So I'm moving away this time. I'm moving the opposite. So what's my new decimal? 7.08. always times 10.
To the power of negative.
And I look 1, 2, 3, 4, 5, 6, 7, 8. So to the power of 8.
Yep. No, negative 8.
Why negative?
Because it's a decimal.
Because it's a tiny number. So it has a tiny exponent. All right, so let's see if you can figure this out, smarty pants. What if I gave you this number? 4.13 times 10 to the 5th.
It'd be 413 and 10 zeros.
No. What?
413 and 5 zeros.
Not 5 zeros.
3. No, 2.
Okay, so here's what you'd look at. We'd kind of undo it. We'd find the decimal, right?
Got it.
Found it. It's right here. Now, it's already in scientific notation. But what does scientific notation mean? What does this 5 mean?
That's how many times you moved.
That's how many times I moved it, right?
Yeah.
So here's my decimal. So could I unmove it 5 times?
Yes.
And it's a positive, so it's going to be a big number, right? So there's 1, there's 2, there's 3, there's 4, and there's 5. So what does that mean?
413.
Oh, I can fill those in with zeros. So my answer is 413000. Because this 5 tells me I take my decimal and I'm undoing it, so I'm going to move it 5 times. It doesn't mean 5 zeros. And that's our problem sometimes. All right, so let's try this. Negative 8.12 times 10 to the negative 9th. These ones kind of make me crazy. Because I always run out of room. All right, so let's use the same idea, right? Negative 8.12. There's my decimal. Yeah? Here's my decimal. And this negative 9 tells me I move my decimal 9 times. But it's negative, so it's going to be a tiny number, so I have to move it the opposite way. And here's why it drives me nuts. Because I have to move it 9 times, I'm going to run into this. So when you see a negative exponent, write your decimal to the right. So then you can move it 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to rewrite it. 0.0000000812. Don't forget that negative. Now here's my trick, ladies and gentlemen. I told you when it's 5, it does not mean 5 zeros. True? But if it's negative, guess what that means? 1, 2, 3, 4, 5, 6, 7, 8, 9.
What?
If it's negative, now here's the trick. This gets counted. So it's 0.000. You cannot say, oh, I'll just put down 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then put my decimal. No, 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 no. It's 0.0000000. If only for negative exponents. Only for negative exponents. I don't like saying this. I don't like saying like, oh, you should use this so much. Because what happens is you start rushing and all of a sudden you do this problem up here and you put 5 zeros on the end. Because you're like, well, you told me that the exponent is how many zeros. No, it's not. The exponent is how many times you move. The exponent is how many times you move. It is not how many zeros there are. It just happens to coincidentally work. It's how many zeros are there in a negative. If you remember that it's 0 point. Numbers do not start with a decimal. Numbers start with a value, then a decimal.
So can we put a 0 decimal and then 8 zeros?
It's a total of 9 zeros.